Hello friends, this is your computer networks class. In previous class we have learned stop and wait ARQ. Now in this we will learn sliding window ARQ. In sliding window ARQ, the transmitting window size is n. Here the transmitter will send n frames continuously. In previous one, in stop and wait ARQ, the transmitter send only one frame at a time and wait for acknowledgement. But here the transmitter send n number of frames continuously without any acknowledgement. Here the overlapping happens means there continues one frame, then after one frame, then after one frame without any wait time. Continuously it happens. Continuously it transfer the frame by frame to increase the utilization of the channel. What is the utilization of channel? Channel utilization means in one cycle time, how many bits or window packet size is transferred. So in cycle time, how much time transmitter is busy to sending the frames. So the packet size transmission time into the window size. If for one packet it take 1 second, for 10 packets it take 10 seconds, and if the cycle time is 10, then efficiency will be 100. So one efficiency means 100% utilization of the channel. So here there is a transmitter having n number of window size and the acknowledgement for the receiver from the receiver end. For maximum of full utilization, there is a formula here, the cycle time, which is equal to the transmission time of one frame into n number of frames. If the transmission of one frame is something like 1 and the cycle time is 10, then we should have to send 10 more frames for 100% utilization of the channel. So the channel utilization happens here. The link utilization or throughput. Total number of bytes transmitted in the cycle time is called throughput. What is throughput? Throughput says that if we have a bandwidth of 10 Mbps, okay, we have a bandwidth of 10 Mbps, but we are using only 5 Mbps bit bandwidth. So the what is throughput? Throughput is a 5 Mbps. What actual bandwidth we are using is called throughput. The formula for throughput is this. Here the total cycle time or transmit means that the packet size is this packet size, a window size. So the packet size into window size, we get a number of it we have transferred and how much time we have transferred in cycle time. So the bit we get in 1 second. Here one per unit time, how much bits we have transferred. What is bandwidth? Bandwidth says that how much maximum number of bits we can transfer for the channel. Okay, how much maximum number of bits we can transfer in per unit time, and throughput says how much actually we are transferring number of bits into the in per unit time. So bandwidth say that maximum and throughput says that actual bits we are transferring into the channel. I have another formula for throughput is efficiency into data transfer rate or bandwidth. Modification it comes after modification in this formula. So the optimal size of the window optimal size is that for maximum utilization, what will be the size of windows. So again same formula. If the cycle time is this, if the cycle time is 10, what is the window size? What is the window size for optimal window size for 100%? For 100% utilization, we have frame transmission time. If the frame transmission time is 2, then for 12 window size is 5. If the transmission size is 1, then we need a window size 10. So the maximum utilization, what should be a window optimal size, window size for maximum utilization of the channel. Okay. Now in sliding window, the transmitter window size is n length. Okay, the receiving window size is also n. So the total number of sequence required to represent the n length frame, total number of sequence is n. Here the n sequence from 0 to n minus 1. But sequence number start from 0, so it becomes n minus 1, 0 to 1. So there is a n minus 1 number of sequence. Total number of sequence कितने होंगे? The total number of sequence is equal to transmitting window size. Okay. So here let's take example. Here there is a 4 number of frames. Here the sequence of the frame is 4 number of frames and the sequence of frame is 0, 1, 2, 3. Sequence start from 0 to 3, but the sequence number is, there is a 4 number of sequence, 1, 2, 3, 4. Sequence number is 4. Sequence number of sequence is 4, but it starts from 0 to 3. Okay. So to represent the sequence number, we need a 2 bit, because to represent 4 digits we need to be a 2 bit. Okay. So in this condition here, the transmitter send 4 frames continuously toward the receiver. Receiver receive the frames and send acknowledgement. After getting acknowledgement, transmitter again send next frames 4 to 7, having sequence number 0, 1, 2, 3 again. So receiver receive that frames and send acknowledgement. This will happen. So the timeout, what is the timeout? Here means that if there is a loss of packets, then how much times after that it will transfer the packets. So the timeout will be the round trip time, greater than round trip time. Okay. What is the problem comes in sliding window? In sliding window protocol, the problems comes if the transmitter transmit 4 packets, okay, and packets received by receiver, but if the acknowledgement of all packets are lost, then what happens? After some waiting time or time out over, if the acknowledgement of all packets has been lost, then after some time or time over time, transmitter send again all same 4 packets to the receiver, but the receiver already have received these 4 packets, but the receiver already received those packets. But here the receiver won't able to identify that the upcoming frames are same to the previous one or it's different one. That is the main problem in sliding window. Okay, here the receiver end won't identify the newly coming 4 frames are identical or duplicate or previous one. So this problem comes in sliding window. So these problems can be sorted out by and another 2 protocols, go back ARQ and selective repeat ARQ. So that process will be studied in later. So here same thing, sequence number to represent. Here in previous one there is a 0 to 3 sequence number. To represent this sequence number, we need to be some number of bits. So this is a formula. Here we put 3. Total number of sequence. There is 0, 1, 2, 3, 4 number of sequence. So we get 2. So 2 bit of 2, we have to require 2 bits to represent this sequence number. Okay. Thank you. For notes, you can visit our Telegram channel, with the description. Telegram channel's description and link in the description. You can visit it and download the complete notes